suggestion. If you can't, if you need to copy and paste to keep up, that's cool too. Another thing is make your terminal as big as you can. You notice my terminal is just like my full screen. That's just a general terminal, being in the terminal suggestion. It makes it easier on your eyes to read it. And if you get stuck, let me or Jack know in Slack, and we'll try to help. I would rather just you ping us, and I can try to assist there while Jack's talking, or vice versa, and that would be better than getting stuck, because I want everyone to be able to follow along today. So we're going to do a bunch of sort of basic SQL keywords for the morning time, and then we're going to have lunch at 12 Central, and then we're going to do some more exercises after lunch. Around 3 o'clock, we're going to do a data modeling exercise. So in the data modeling repo, there's an explanation of how that's going to go, but I'll be leading us through some whiteboarding. And then we're going to break around 4 o'clock Central, and leave 30 minutes for questions and answers you might have about being a programmer. Completely glossed over the fact that I'm a veteran, but I am. So being a veteran in technology, I'd be happy to answer questions about that, or programming as a career change. And then we'll turn you back over to Tom and instructors. Okay, any questions about the timeline? Okay, great. Again, yeah, we're all in Slack, and send us a message if you have questions. So we're going to start off talking about the reading. I believe you were assigned Intro to Persistence, and kind of covering that. So let me get that set up. Okay, are you all seeing slides, just like a big giant white slide?
Yep.
Okay. All right, let's get started. Okay. So we're going to start off today talking about the database reading. I think you're still being assigned called Intro to Persistence. If not, fill in all the gaps. But so this is going to be talking about the concepts of data and why we are teaching what we're teaching today. I'm going to start off with an opinion that I know Jack and I share that really colors everything that we say today. Databases are important. Databases have a lot of value for your business or the business you're working for. They can be very sensitive. There's a lot of information in there that you don't want the world to know. The database code you write is probably going to outlive almost any other code you write for the application. You know, you might change the API, you might change the front end, you might change the mobile applications, but the database code's going to live for longer than all of that. So to sum up, databases are really important. This is something that Jack and I care a lot about, and so we're really, really excited to be here today, as he said. So we're going to break down databases in this 30 minutes into 4 sections. Persistence. What is persistence, and why do we need it? Secondly, we will look at a common solution / anti-pattern to persistence called a spreadsheet, and we'll see what it is lacking. Third, we will talk about a very popular approach to databases called a relational database. And then fourth, we'll talk about a collection of tools that come with modern databases called a RDBMS, Relational Database Management System. As I said, this will be It's gonna be about 28 slides in about 25 minutes. Okay, part one, persistence. I think there was a good definition in the reading. Would anyone like to offer a, could anyone give me like a working definition of the term persistence?
I think it's the ability to like save your data so that it persists beyond the immediate instance of running a program.
Yeah. Yeah, that pretty much sums it up. The very perfect book definition is continuance of an effect after the cause is removed. And this really gets to a core idea about computers, which I would describe as data is transient. You might have heard the phrase that the universe tends toward entropy, and that's definitely true of computers. Data doesn't stick around. It only lasts as long as we tell it to last, and not 1 second longer. It doesn't have any intention to stay longer than it's told to stay. And two programming concepts that kind of allude to this are scope and memory. So we see this in a programming concept called scope, and I wrote a little anonymous JavaScript function here that adds two things together, A and B. These variables A and B, they have a scope, and their scope is the anonymous function. So they can't be referenced outside the function. They don't mean anything outside of the function. Once that function has been called and they have been added together and returned, they're just sitting waiting to be freed up. In a language like JavaScript, that's done through a process called garbage collection. In a language like C, you have to do that yourself, but you're always getting rid of that data, and it's eventually being deleted. Memory is the other part, like the RAM on your computer. It's holding information, but it's slowly getting rid of that information all the time. It's not intending to hold on to it. So you have to tell the computer to hold on to something. And there are a couple of tools we use to facilitate this. The first is a database. So some people call it data store. The symbol for a database is a tower with disks in it, but the only thing I could think of that looks like a stack of pancakes, so that's what I went with. Gotta have some emojis in your slides. So the way we interact with a database is through a language called SQL, structured query language, or SQL. And then we have the RDBMS, which is the collection of tools that you use with a database. And then finally, we have the ORM, which is object relational mapping. We'll be talking about ORMs a little bit today. They are known as an abstraction. They're an abstraction of the database. Is that a term you've encountered yet? Does anyone want to take a stab at what the term abstraction means? If you haven't gotten into that yet, that's cool too. Yeah,
I think abstraction.
Yeah.
Oh, sorry. I think it would just be kind of like hiding something from your user, sort of like you're abstracting away a layer, so you're making them not have to really worry about maybe part of your program, and they can interact with a higher level of it that might be easier for them to understand.
Yes, yeah, that's exactly right. And the reason we're not covering ORMs today is because we're not interested in the abstraction. We're interested in the thing that it's abstracting away, which is the SQL. And I think later on the abstraction is very, very useful, but that's not kind of the approach that we take. Okay, so persistence is continuing in effect because the data is always going away, and these are the tools that we use to do that. So let's look at one way we could store data, and that's a spreadsheet. room full of people from different backgrounds. I always have a few people who are like really good at Excel, some analysts perhaps. To understand what a database is, I like to look at it from a different angle to try to understand what a database replaced. And the thing that I'm talking about is a ledger, or the more modern term for that would be a spreadsheet. So I have a book that I own at my office in Chicago that I probably never will go back to. That's called The Manga Guide to Databases. It's like a pretty goofy book, but I actually think it's a pretty good book too. So it's set in this magical kingdom that you see in the background, and their kingdom is trying to track its fruit business. And this fairy on the cover teaches the kingdom how to organize their data, starting off with something called a ledger, which is that book, which is very similar to a spreadsheet. And the citizens of the kingdom eventually decide the ledger isn't good enough, and they adopt a relational database. What this book does is it presents a thought experiment a lot of people go through when they're learning about databases, to understand step by step why a database isn't a viable solution for web programming. I'm not going to go through that exercise today, but it's actually fun, and I recommend it. But we will be talking about databases nonetheless, because I think that databases give a pretty compelling clue to why spreadsheets give a very compelling clue as to why relational databases exist. All right, so this is just a random spreadsheet that I pulled down from the internet, tracking some money. Who is the person who would use a spreadsheet like this? So it's like tracking a balance sheet with some percentages, cash flow in, margins, capital expenditures. Like what is a job title of a person who would use this?
Accountant.
Yeah, that sounds right. Accountant, like a financial analyst or something. As a data storage tool, it's really good at some things and really bad at other things. In what way does it not measure up? In what way could it fail to be useful? I think there's a lot of answers to this question. What can't this do?
It can't relate any of the data to any of the other data.
Yeah, the data is not really related. I'll just blow through a couple of things that I think are missing here. Can two people use this at once? I think Excel, and definitely the cloud Excel, sorted that out, but can 100 people use it at once? In database lingo, we call that multi-tenancy. Another question is it fast? Probably not that fast when you load a spreadsheet up on your computer. What if we need it to be fast? That would be the performance. What if we want to know deep and detailed information? In database language, we call that searching. You can kind of do that, but it's limited. What if we want to change the way we present this information? Like, instead of just showing it in this block of text, we want to completely alter how it's presented. In database language, we call that a query. Pivot tables kind of do that, but pivot tables are not something most Excel users know how to use, I wouldn't say. Okay, what if we want to restrict access? It's pretty hard to do with Excel. I think you can like lock who can use it, but it's not a very, at least the desktop application isn't like very, very featured in that way. What about controlling what goes in the cells? Is there any limit to like what somebody can type into a cell? I don't think so. Database language, we call that data validation. what if we want to ensure that the data never gets corrupted? Well, that's tough to do if it's just sitting on somebody's computer, but you could be backing it up all over the place, I suppose. We'd call that data integrity. And the last one I think of is, what if we wanted to connect to this database remotely, this spreadsheet remotely? So it's sitting on my computer and you want to work on it. There's ways around all of this using other tools, but it's not something that is built into the spreadsheet software itself. That's a list of many things that this spreadsheet doesn't really do. The data on the spreadsheet is probably very important, and yet despite how impressive the spreadsheet software is, it prevents us from doing a lot of things, and it's not optimized for those things. And that's the reason a spreadsheet is not going to work for most web applications. Okay, so hopefully I've sold you somewhat on the value of a database. How should our database be designed? The solution that you're going to learn today, and I think is most important, is relational. In a lot of the SQL workshops we've taught, somebody usually early in the day will come up and ask about NoSQL databases like Redis and Mongo. And those kind of databases are very popular, and they sound cool, right? NoSQL, like it's like SQL, but none of it. I think it has a very buzzy sound. That's a tool that you might choose to learn, or you might get an opportunity to learn in your job. But I think there's a strong reason to start with learning relational databases. This is a screenshot from the Stack Overflow 2019 developer survey, where people ranked the most popular databases or their favorite databases, and they could select all that apply. So we have MySQL in first place, Postgres in second, Microsoft SQL Server in third, SQLite in fourth, MongoDB in fifth. So the top 4 most popular databases are relational, and you don't get into a NoSQL database until the fifth ranking. And I think there's a bias here towards stuff that people use for work. Like I wouldn't ever say Cassandra or Couchbase or DynamoDB because I've never used those before. So I don't even know if I like them. So I think people put stuff that they actually do on the job a little bit more than they think they do when they answer questions like this. So relational, it has been and it remains the dominant database model. And you might be asking yourself why. I think the reason is that relational databases align very closely to some popular ideas in programming that should be mentioned at this time. The first is users should not know how the data is organized. Let's look at that spreadsheet. Okay, so what is the interface you use to edit the spreadsheet? Like if you actually want to edit this, how do you do that?
By clicking on the cells and just writing into them.
Yes. It's the spreadsheet software itself, the Excel or the numbers. The software is the form. When data is organized this way, the interface matches the structure of the data 100%. They're totally coupled together. On the web, that has risks because sometimes we don't want users to know the structure. That's called leaking the database design, and it's not desirable, right? If you wanted a user to fill in any information here, it's all here. They can see everything. So we don't want users to know how the data is organized. The second idea is user activity should remain unaffected when the internal representation of the data is changed. Think about a company like Facebook and just try to imagine how their data structure has changed since they started off. Right? They had a user 15 years ago and they have users today, but I would guess that the data model for that user has changed probably drastically in that time as their business has evolved. But as a user, your experience has continued interrupted, and it's mostly unchanged. And relational databases support this goal because of the way that they're organized. And so let's look at a relational database structure for an application that I've worked on called Today I Learned. So this is TIL. It's a app with short posts about technology, and it has a really simple data model. You have posts, you have developers, and you have channels. So this is a post, and it has a developer who wrote it. So it belongs to a developer, and it has a channel that it belongs to. So there's basically 3 tables, and this is the database structure. So this chart is something called an ERD, an entity relationship diagram, and you can make one yourself, or you can use software to make one, which is I think what I did probably 4 years ago at this point. So these are those three tables. You can see on the left of each little bubble you have the table name, and then on the right you have the fields that go with the table. The name of the field, and then the type. So under channel you have name is text, and then Twitter hashtag is a string limited to 20 characters. And then the arrows show the relationships. So a developer has many posts, and a post belongs to a developer. That's what that arrow between them is representing. The same for the channel. The channel has many posts. The post belongs to the channel. So they're both pointing at the post. If I made a form for this application that wanted to get new developers into the database, users could do that, and they wouldn't ever have to know about posts and channels, because a developer doesn't necessarily have any posts, right? I could restrict that, but they could have none. And because they don't have any posts, there's no channels that are related to that non-existent post. So I could make a form just for the developer, and a user would never know that there's anything even called a post or called a channel. There's no way that they'd be able to draw this picture from having been shown that form. So this structure allows us to hide the structure of the database from the user. And there's a couple of relevant programmer quotes that I'd like to just throw out here, both from a Ruby programmer named Sandy Metz. Always delay making design decisions until you need to. We keep these tables separate, yet related, right? Because we don't necessarily know what the final structure, the final arrangement of them will be. If we ever want to rearrange the pieces, if we ever want to get rid of the pieces, they're not sharing space on a spreadsheet. They're just associated with each other. And the bookend to this quote for me is, we'll never know less than we know right now. Also, Sandy Metz. We don't commit to a database shape, and we thus give ourselves the ability to change. So the relational model adheres to these 2 programming principles. How do you actually get a relational database to work? This is with a tool called an RDBMS, Relational Database Management System, which provides a lot of the functionality. So Postgres isn't just a database. It's actually a relational database management system, because it provides the following tools. We have CLI tools, scaling, data validation, data integrity, and searching. I'll talk briefly about each. Okay, CLI tools. So CLI command line interface. Postgres provides a variety of CLI tools. One of them is something called the REPL, which stands for Read, Evaluate, Print, Loop. And the REPL for Postgres is called PSQL, PSQL, and that's what we're going to be using all day. It's a way that you can talk to the database. So this is me in the database for TIL, and I've run a command /d channels. So D stands for describe, or possibly display, and then the channels is the name of the table. So what this did is it shows me the structure of the channels table. And you can see we have the columns, we have the types, we have information about whether they can be null or not, which we'll be talking about a lot today. And then we have a column for default. So you can see that the ID column has a default. You don't have to say what the ID column is. It's going to use this function here to determine what the next ID should be. Then we have some indices, which we'll also talk about today. And we have references that describe how the channel table is related to other tables in the database. There's a lot going on here. I think at the end of the day, much of this will make more sense. Okay, then we have scaling provided by the Relational Database Management System. Scaling means that the tool allows multiple users to query and update records at the same time, so our program can scale. Next, we have data validation. So it provides our ability to validate records and relationships. We want to keep the data that gets into the database very clean, and we want it to have very high integrity. So data validation provides that. And then we have data integrity. Ensure that critical updates like debiting one bank account only succeeds when crediting the other also succeeds. So we can, through something called a transaction, we can control what happens if something goes wrong. And we can prevent the data from ever getting in a nonsensical state. This is something we'll look at today as well. If I take $50 out of your bank account and then I try to put $50 into my bank account and the program crashes, what happens? Postgres has a solution for that. And also it prevents unintentional changes to information. And then we have searching, where we can return records that match multiple complex criteria. That will also be a big part of our day today. Okay, so to wrap up, we talked about persistence. We talked about spreadsheets and why they don't really work for the web. We talked about relational databases, and we talked about RDBMSs. This is one solution to persistence, and it happens to be very popular. It's the main one that Jack and I have both invested for our careers in. And so we're, again, really excited to be here today to be talking about it. And for the rest of the day, we're going to be actually doing SQL, typing it into the REPL. So before we take a break to set that up, can I answer any questions about the stuff we've covered thus far?
So for spreadsheets not being able to do the job, that's because they're not scalable, because they don't support multi-tenancy. And without using pivot tables, you can't show relations. Am I missing?
Yeah, that is several of the that's definitely several of the points. It's the multi-tenancy, the relational stuff is difficult. I think you can do it through pivot tables. That's not something I've explored that much. It's hard to connect to them remotely. Like there isn't a command line interface that's exposed. Yeah, let's see. It's hard to control what people put into the cells. It's hard to control access in general. I mean, Excel probably has like some different roles, like read only or read write or admin, but like, those are defined by the program, and you're always going to be limited to whatever their programmers decided they wanted to let you do. You have a lot more control with something like Postgres. That's just a few of the ways that databases really stand out.
Thank you.
Other questions?
Hey Jake, you mentioned that there's like the top 4 were all like relational database models. Are there any like high level reasons why you would choose one over the other? We don't have to go into like every single one of them, but like what are some of the reasons that people go one direction as opposed to others?
I love this question. I think there's like a lot of different answers to that. Sometimes, so if as an employee, sometimes you go to a company and they're all on MySQL, and then the choice has been made for you by joining that team. I say as a new developer, that's the most likely thing that's going to happen. As a senior engineer choosing a database solution, there's so many factors that come into play. So let's just take these 4 here, these top 4 on this list. I'm just stalling because I know Jack is going to give a way better answer to this. MySQL had for a time had a performance edge over Postgres, but Postgres had a data integrity edge. So like if you wanted to be faster, you'd use MySQL. If you wanted to have the most correct data, you'd use Postgres. But those things have kind of like evened out over time. Postgres had all of these databases are trying to match a set of specifications that are made by committees that decide what the SQL standards are. So each of the tools might be farther along the path of implementing whatever the current spec is. So that's a reason you might pick one over another. If you're a Microsoft team, right? If everything you do is Microsoft, you're probably going to use Microsoft SQL Server, just because it's just another thing it's another license for you to buy that's like already easy to do because you're buying a ton of licenses. These, they all have different licensing models. So maybe you want something that's open source versus something that's a paid licensing model like Microsoft SQL Server. And then SQLite, the 4th one on the list, among many other things, SQLite is the default database for Ruby on Rails. So lots and lots of programmers, and that maybe that's true of other frameworks, I don't know, but lots of programmers, the first database they ever use is SQLite because they start off on Rails, and then there's a SQLite database there, and they come to like SQLite. So that's just like a couple of reasons I can think of that among hundreds that would make someone choose one of these over another.
But basically, if you have to choose for yourself, we just recommend just use Postgres, and you'll save yourself a lot of trouble.
Yeah, Postgres has a really passionate following, and they've done a lot of things very well, and they were in this position, number 1 or number 2 when we started teaching this course 5 years ago, and they're still there. So it's a very well managed programming organization, and it's kept up with the demand for it by like continuing to release improvements and features. It's like a very active, very, very maintained project. So it's like if you're going to pick one on this list, like you can't go wrong with Postgres.
I have another question, Jake.
Yeah.
So I'm just trying to differentiate the difference between like MySQL and Postgres. Like when you get MySQL and Postgres out of the box, like what are the key differences here? And I guess the second, like the part 2 of my question, and I can ask it again, but with Postgres, like what is the difference between Postgres, SQL itself, and like PSQL? you know? I guess like, and part 3 of my question is, do all of these databases run off of SQL? I know DynamoDB is no SQL. I don't know, like where's the connection, I guess, if they're not all SQL?
You want me to grab this one, Jake?
Yeah, take it away, Jack.
So to elaborate a little bit on what Jake said before about MySQL versus Postgres, historically, MySQL cut corners to be really fast. And Postgres was slow because it was very, very careful about data integrity. So to give you an example of something that historically was the case, may not be the case anymore, but if you had a character field that allowed, say, 20 characters, and you tried to save 30 characters into it, MySQL wouldn't stop you. It would just silently throw away the last 10 characters. Postgres would throw an error and say, stop right now because there's a bug, there's something wrong here. And similar things like if you were to store an invalid date, well, it would just convert it to like all zeros or something really weird like that. Now, I believe most of those things have been corrected by now, but historically, that was the reputation MySQL had. It was really fast, but it took some shortcuts. Also, things like transactions, which Jake alluded to when he was talking about the consistency guarantees you get, where multiple records, you can update them all at the same time and either all of them happen or none of them happen. MySQL has different storage engines and some of them are super fast, but they had different integrity guarantees. There were like, you had one table in one storage engine, one table in another storage engine. You did some writes and then you did a rollback, like one of them would roll back and the other one wouldn't roll back. Just lots of weird edge cases like that, where Postgres was really, really careful to be very strict and not lose your data, which is kind of an important thing for a database. But because of that, its focus there historically was very slow. I say very, it was slower. They've tended to converge a little bit nowadays. So MySQL is a lot safer out of the box. Postgres is a lot faster out of the box. But they still have various edges one way or another. Like the out-of-the-box replication story is, as I understand it, is a bit better on MySQL than it is on Postgres now. But Postgres has a much better system if you want to actually write things like stored procedures. It has a much more extensive multi-language system, actually. You can write Python code in your database. You can write Perl. You can write its own SQL language. You can install an extension. You can write JavaScript. You mentioned, let's see, I'm trying to think what was the other question about the core SQL stuff. What is the difference? There's a, go ahead.
Yeah, I guess I should just, since I need to know my place as a student and not try to know all of this, I should just zoom back in on Postgres. So when we open up Postgres out of the box, what are all of the, I mean, what is like, yeah, I guess what's like, when we're interacting, I know Jake kind of covered it, but like, is that when you type in PSQL to your terminal and you open that, is that a shell for interacting with Postgres? Yeah, I'm just trying to understand.
Yeah, you could think of it that way. So the Postgres project, the Postgres server itself is a server. The only way you can do anything with it is basically establishing a network connection to it and talking its protocol. You can connect over TCP, you can connect over Unix domain sockets. And the psql command, that is the client shell that does that for you. So you can just start that and you can directly type SQL commands into it. But as far as the Postgres server is concerned, it's just another client. If you have, a Python app that's going to talk to Postgres, the Postgres server doesn't see the difference, because your Python application and the psql thing are all talking the same language. It's almost like a web server. You can use Firefox or you can use Chrome. And aside from the fact that it'll send, this is my user agent, the server doesn't know the difference. They're both speaking the HTTP protocol. So psql is just like a browser that connects to your Postgres server. And there's many different browsers, or there's many different, drivers, different applications that can talk to it.
Okay. So, are you talking about in general? Or there's many different ways to talk to it within Postgres.
Well, what I mean is, again, to use the analogy of a web server, you know, you can use Firefox and you can browse a website. You can use Chrome and you can browse a website. You can use curl and you can, you know, connect this stuff at the command line. Postgres is the same way, where it has a specific language it talks. And if you just want to explore it, PSQL is probably what you're going to use. But if you're going to write a program, you know, like if you're using Python and I think you'd be using Django there, you know, it will actually talk to Postgres directly, but it'll use the same language.
Okay, yeah, that helps a lot. Thank you.
Other questions? Okay, we're gonna take a break here, and that will let me and Jack get set up with the coding portion of the day. And anyone who doesn't have the repo pulled down from today can pull it down, and then get your Postgres set up. So we'll just take a rough 10-minute break. We'll meet up at the top of the hour. Okay, so it looks like people are starting to come back. Jack's going to be driving us through the first SQL lesson on the Phonebook. So you'll want to get this file here opened in a text editor and a terminal. And I think that's the basic things you'll need. If you can get it set up like this, is this VS Code? You can get it set up like this, that would be pretty cool. What are you all using for text editors? Is it VS Code? Yeah. So a setup like this would be ideal if you could.
Yeah, so it looks like we're ready to go here. I've got my screen shared. I'm not sure. Can everybody see my screen?
Yes, sir.
Cool, cool. Okay, and you're welcome to use whatever terminal you want. For convenience and sharing, I'm just going to use the built-in terminal in VS Code. But you know, if you want to use iTerm or you know whatever you have local on your machine, that'll be just fine. To start with, let's go to this. Make sure you're in this SQL workshop directory. Then from there, we are going to change directory to Phonebook. And you'll notice we've got several subdirectories in here. We've got a bunch of different lessons, each of which are roughly an hour or so long. And we've actually got a bit more lessons than we have time today, so we're just going to choose a sub-selection of them, but you've got the repo and you can follow along after the fact if you want some extra stuff. To start with, we're just going to create a database. Now, we're going to run this command here, create DB Phonebook. Create DB is a built-in Postgres program that comes with the whole RDBMS. Like Jake said, there's actually a whole set of tooling around the database. It's not just the database. This is one of them. And this one is just a command designed to create a database. And it's a good Unix style command. If everything works, it does not give any output at all because you should, you know, the Unix philosophy is you assume it works, so it says nothing. The next command, and I'll explain what this does in a second, is to import the data. We're going to run this psql-f data contact SQL, and we're going to say Phonebook there. So what this command is going to do is we're running the psql. That basically gets us the REPL or the shell where we can start talking directly to Postgres. Only instead of typing it in, the -f says, I want you to load this file instead and just run this SQL file. And then we have to tell it which database we're going to use because a relational database management system can have multiple databases. one server can host multiple databases at once. So we have to tell it which database are we going to use. And we're going to use this Phonebook one that we just created. And it spits out a lot of information. I have my PSQL customized a little bit where it shows me how long each command took. So I'm guessing that most of your commands probably just show that insert 01 and you don't see the time. It's probably what happened. And this stuff is obviously really important if it's working or not. So like Jake said earlier, we've got two of us here. So when one of us is talking, the other one is able to help. So if you're trying to do this and it's not working, if you can ping Jake either in the Slack channel or in the Zoom chat, and Jake will try and help you get going with this. Next, what we're going to do is we're just going to run psql phonebook. This is the same command as before, except without the -f argument. And we're telling it here, I want to connect to the phonebook database, and I just want to start typing. I don't want to actually run a file. So you should see something like this. In particular, you should see Phonebook and this weird little prompt here. You'll probably see something a little different here where I have like jack at local:5432. But again, just like you may have learned that you can customize your prompt like in Bash or Z Shell, you can actually customize your prompt with PSQL as well. So I have a little bit of a custom prompt here. During some of the breaks during the day, we talk about just some extra stuff. So if somebody reminds me, or Jake, we'll talk a little bit about the pSQL customization then. But let's start with actually some SQL. I mean, it stands for Structured Query Language, so we're going to start with actually doing a query. So let's run this very first select statement here. I'm going to say select name, phone from contacts. Let's run that. Should see something like that. And now we're gonna, let's talk about what that actually does. So SQL is a very old language. It goes back at least into the 80s. I think the roots of it might go back even into the late 70s. And one of the things that was popular at the time was trying to make languages that were somewhat human-like phrasing, where you actually, use more human words than computer words. So you end up with stuff that is a little bit like a sentence, select name and phone from contacts. It also is kind of reminiscent a little bit of like the BASIC language where there was a lot of words, or I think old AppleScript is even that way as well. But how we'd read this is the first word there is select. So that's starting a select statement. Next, we tell it which columns do we want to select, or rather, which expressions do we want to evaluate. And we'll get into that difference a little bit later. Then where do we want this information to come from? Well, from, and we give it a list of relations or tables. And in this case, we're just going to say the contacts table. So this command should get us every row from the contacts table and the columns name and phone. And I suppose we should give some definitions. I know, with a class this large, I'm sure some of you have already seen a fair amount of SQL, and some of you, this is probably the first day you're seeing it, or the first you saw it was, your homework reading. But you can think a simple way of picturing a table is a spreadsheet with just a single sheet. I know Excel nowadays, you can have like multiple sheets in a single file, but if you picture a table as just one single grid, that's a pretty good description of a table. At least it's a good enough working description for now. The next thing we have here is the star. We can say select star from contacts. And select star is shorthand for saying, give me all the columns. So that's pretty straightforward. So that also tells us here, oh, the contacts table, well, it only has those two columns. Now, you probably guessed here, actually I didn't give the preliminary here, that our domain that we're going to be working with here is a phone book, kind of like you might have on your mobile phone. You have your list of contacts, and eventually, you're going to have records of like who called who and when they called and that type of stuff. For the moment here, though, we're just going to work with contacts. So one of the big things with SQL is we can ask it questions and we get answers back. And one of the ways we can ask it questions is we can say, filter which rows actually come back. So we're going to run this command here of select name. So we only care about the name column. We tell it which table do we care about from contacts. We say where. This is where we apply filters. So we're going to say where phone equals, what is this, 579, 804, 9800. And lastly, we have the semicolon. Now I'm guessing at some point here, somebody is probably stuck and cursing their terminal, like, why am I hitting enter and nothing happening? Why is this thing stuck? So let's go back to this select star from contacts. Notice I hit enter, nothing happened. What is going on here? SQL lets you have multi-line statements. The only way it knows the statement is done is when you hit the semicolon. So I'm guessing that at this point, since we have like 25 students, somebody, or probably several somebodies, since when we've done this class in person with 10 people, almost always somebody gets stuck here. So I'm guessing a few people are stuck here. If you don't hit the semicolon, it never runs. You can see if you're stuck by, like, if you start typing some stuff here, you notice how the prompt changed a little bit, where it was equal hash symbol, whatever you call that, octothorpe. And then when we're stuck, it says minus octothorpe. That's telling us that we are editing a single statement, but it's not finished yet. If you ever get stuck here, if you hit Control-C, that just breaks out of wherever you are. So if you're stuck, hit Control-C, and then you can start typing again. Now let's look at this select statement with the where again. As you noticed, I purposely broke this up into multiple lines. It gives us an example of, like, oh, if something breaks, that might be why, because it might think you're in multi-line mode. It also gives us a chance to make this a little more readable. You'll often end up with SQL statements that can be 10, 20, 100, 200 lines long. And it becomes a lot, SQL is not terribly easy to read to start with, but it's even harder to read when you mash everything on a single line. So there tends to be a little bit of a style of separating each clause of the statement on its own line. And if you have multiple sections within a clause, even breaking them up. But the new thing here is the where clause. So the where clause is an expression that is evaluated for each row. And if the expression evaluates to true, the row is included. If it does not evaluate to true, the row is excluded. So let's take a look at this, and we're going to add this phone expression to the select clause. This actually demonstrates a couple things we talked about before. So that second column, which doesn't have a name, that's why it's saying question mark column there, is F for false and T for true. So you notice this line here of Sybil Nicholas is true and all the other ones are false. This gives us insight into a couple different things. One, in the select clause, normally we are just selecting column names, but to be fully accurate, what we are selecting is expressions. And an expression can just be a column name, or it can be, arithmetic, it can be a Boolean operation. And in this case, it's the Boolean operation. We're saying phone we're testing phone equivalent to this number, and it returns either true or false. Now, when we put this in the where clause, for every one of these columns, it evaluates it and it says, is this true or false? You know, is Miranda Carroll's phone number that? False. Is Lydia's? False. Shirley? False. Archie? False. So on, so on, and so on, until we get to this line here, Sybil, which is true, then the rest of them are false. And the where clause will look at those evaluated expressions and it'll only include the ones that are true. And that is why when we run this, we only get that single row out. So I can't see everyone's faces like we can when we're in person. So I can't see if everybody's falling asleep because you get it or everybody is terribly confused. So how are we doing?
Challenge of teaching remotely. Yeah, I've been getting a few direct messages. Please, if you're stuck, send me a message. I will help. But does anyone have questions thus far?
Yeah, it's me, Gio here. So I just got a question. You guys are, when using the commands, are in lowercase, but yesterday we were using them in uppercase. What's the difference?
Good question. So there is no difference, actually. SQL is, or at least Postgres in particular, but I believe this works everywhere, is actually case insensitive. It is a very old language, like we said, and it goes back far enough that a lot of people would have been doing this on a terminal that did not have colors even. So as a way to make it easier to see, they would use uppercase to distinguish keywords from, you know, non-keywords. And that tradition or style has been carried down, and typically you will see that in a lot of documentation. But it's entirely unnecessary. And my wrists get sore enough from the amount of typing I do. I don't wish to hit any more keys than necessary. So I just go and I just use lowercase. And if you're using a modern text editor, you have syntax highlighting anyway. So if you like it better uppercase, you're totally fine to do it, but it's not necessary. Okay, we've got a couple exercises here. So let's work through these exercises. If you're stuck, now is a great time to ping me or Jake. We're gonna spend about, say 2 or 3 minutes, hopefully here, then we'll go through them together. All the exercises that we're going to do today, there's another file in this directory, the solutions file, that has all the solutions for our exercises. Now I suggest, you know, obviously try and do it yourself before looking at the solutions. But like I said, we're gonna spend about 3 minutes here, give you time to work on the exercise, and then we're gonna continue on. If you have any questions, now is a great time to bring up questions, either for the group or directly to me or Jake.
One quick question. How do you do ignored case in your like matches?
That's a I think something we're going to be covering very shortly. So it's a good
yeah. If you scroll down a little further, I think we have that as one of our things. But preview of coming attractions, there's another expression called I like, or there's another operator, and that's for insensitive. So you could just use I like. Another way in Postgres is there is a specific type of text column that is case insensitive. It's called CI text. That's another thing you can look at. And then the traditional way is actually to use the upper and lower functions. And you can just say convert both sides to uppercase or convert both sides to lowercase and then compare that.
On multi-line queries, is there a way to go back to a previous line to make an adjustment, or do you have to just kind of write it out and start over?
So there is a command that you can use. There's a meta command called \E, which actually lets you use your text editor directly instead of typing it in PSQL. Another thing you can do when stuff starts getting more than a couple lines is you can just make your own SQL file, and there's a meta command \I, which lets you just run a file on your hard drive. And that's what I tend to do mostly if I'm doing something longer. Like, we got another minute here, I'll just do this. So like, let's say I had, select star from contacts, and this was some big long query. I could save this as I'll just say temp.sql. And that's the type thing I'll usually do when we have a long query. I'll work on it in a file. This also gives me the syntax highlighting. I'm an old school person who uses Vim key bindings, so that lets me use W and V and J and K and all those to do my navigation, which is really nice. But yeah, so whether you use \E to say take me to my editor and then return, kind of like if you're doing a git commit message, is kind of how that works. Or if you just make your SQL file separate and then \I to input and run. But as far as specifically your question of can you go back to another line after you've typed it, there may be a way, but I don't know what it is. All right, so let's look at these exercises then. We've had about 2 or 3 minutes there. So if we want to find the phone number for a person, this is going to be, select, phone from contacts again. The where clause is going to be where the name equals a specific thing. Now you'll notice both with phone and with name here that we are putting single quotes around it. Single quotes are how you do a string literal in SQL. And I presume, I think this is usually like week 4 or 5 of the cohort that we're talking. So I'm assuming you've done a little bit of Python at this point, and like string literals with single quotes or double quotes or whatever, that those are somewhat familiar at this point. In SQL, in several languages like JavaScript and Ruby, and I think in Python, but I'm not sure, single quotes and double quotes are oftentimes interchangeable. That is not the case in SQL. In SQL, they are entirely separate things. Single quote is a string literal, and a double quote is quoting an identifier, as in a table name, a column name, something on that order, a schema name. So you'll rarely use double quotes in SQL, but you will use single quotes all the time. In the terminal, one other thing let me mention here is some shortcuts. The up and down arrows go through your history. In fact, basically, PSQL uses, I believe it actually uses the readline library directly, but it basically works like Bash or Z Shell, whichever one you're using, where you can do up and down arrow through your history. You can use Control-R to search through history, do a reverse search. But up and down arrow is probably the most important one for the moment. All right, so for our second exercise here, who has this phone number? Well, this is basically the same thing we did above. I'm just going to copy that number here. Okay, so what if we only know someone's first name? The equal looks for an exact match, but the like operator allows us to put in wildcards. So let's run this command here. Select name, comma, phone from contacts, where name like Tammy with a %. The % is the wildcard character. It matches any number of any characters. And it matches it positionally. So for example, if we wanted to find you know, somebody whose name ended in GER, well, we get both of them there, Tammy Reinger, Kayleen Behringer. And this will be used occasionally, you know, just to find matches. You can even do stuff in the middle. So like if we wanted to find something like this. All right, so with that in mind, let's try and do this, find the phone number for somebody with the last name of Herman. Give you about a minute to do that one. Should just be a quick change from the examples we just did. And again, these little exercise times are ideal. If you have any questions, you know, please speak up.
I just wanted to jot down for my notes. I know we went over it. I didn't get all of it. With the single quotes and the double quotes in PSQL.
I'm sorry, say again?
What's the difference between the single quotes and the double quotes in PSQL again?
Sure. So single quotes are a string literal. So in this case, like we have the string literal of, you know, Tammy and then the % sign. The double quotes are quoting an identifier. So like, for example, when we have like select star from contacts, we could put double quotes around contacts. And that's saying this is an identifier. It already is. Most of the time it's not necessary because a very strong rule of thumb is to use all lowercase in Postgres names. But you actually don't have to. You could name it as something else. And here's an example of something like that. Let's say we have a name and we really wanted to have it come out as a full name. The as keyword lets us rename or alias a column or the output. So it'll say full name now. But what if this was for a report and we really wanted it to be English? We wanted it to be, you know, something like this. Well, this is not going to work. Quoting or double quoting here, this is how we have an identifier that has casing and that has spaces in it. There's one thing peculiar to Postgres is it does something called like case folding by default. So I could say select star from contacts, and even though the actual name is lowercase, it'll still work. I don't know why my VS Code terminal is kind of lagging here. Type it and it takes a couple seconds to show up. And that's because the contacts thing with the casing, it automatically downcases it. Unless it's quoted, in which case it takes it literally. So if I do this, it's going to complain about, you know, yeah, no table. So yeah, to summarize that, single quotes are for string literals, double quotes are for identifiers.
Thank you.
Mm-hmm. Okay, so for the solution to this exercise here, we select phone from contacts, where name, like, then we're going to start with the wildcard at the beginning. and that gives us the phone number.
So, quick question. So, because there is no first name and last name column, we use like to get the last name. But if there were two different columns, then we could have said where last name equals Herman, right?
Exactly, exactly. Yeah, one thing that, especially in this lesson, we're going to do is we're kind of starting in a certain respect by doing things the wrong way. Like, you shouldn't have a name field with the whole name like this and then try and pull out the first name and last name. If you really care about first name and last name, they should be separate columns. And what we're doing here is we're going to purposely run into that problem, and then we're going to correct it. That's one thing that I found helpful when learning and difficult when learning when I don't have it, is knowing the why. So even though we are a relatively young industry, people have been programming, for 70 plus years in one form or another. And we're built on layer upon layer upon layer. And what we do today is the solution for problems that people had 10 years ago. And the problems they had 10 years ago actually were the solutions to the problems 10 years before that. So we end up with things where we just say, or even just assume, oh, we're going to do X. But the reason we do X is because there was a whole string of A, B, C problems that the solution of one thing led to another, which means we finally do it this way. So we're going to purposely run into a few of those little problems along the way to explain, why do we actually do it this way. And this case of splitting last name and first name, that is an example of that. Okay, so this next one here is pretty simple. I'm just going to copy and paste and run this. This ought to be fairly self-explanatory. Lets us do case insensitive. So there, in this case, the D is capitalized in our real data, but it's still matched because we're doing insensitive like. Any questions there on the very basic select stuff? Okay. Well, now that we...
one more. Is it like space sensitive? I mean, if we put space after quote or after from double space?
It is not. So we can do that. So like, for example, yep, still works.
But what about like inside the quote? Can we put the spaces also?
Inside the quote, you cannot. Because, like, for example, here, if we added a couple spaces, we get no rows returned, because it is actually going to look for DARE space, 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 and it says, oh, nothing matched.
Yeah, that's a great question. Actually, it's one we haven't had before, but I think it might come from you all using Python as your main scripting programming language.
Yeah, it's case. It's a space sensitive.
Yeah. I would say the majority of programming languages are white space agnostic. I don't know if that's the right term.
Insensitive.
Insensitive. So the tokenizer, the thing that's like analyzing your program is like when it hits a white space in most languages, it just like says, it basically throws it away. It doesn't add it to the tokens. It says this isn't important. But in Python, white space matters. So that question makes sense given where you all are coming from.
Yeah, and as far as white space in the actual values, this type thing, this is a good example of why you would want to do some data validation on the way in. And that is, say you have a web form and somebody's typing in their name and maybe they copy and paste it from somewhere, and the copy and paste includes a space or a new line character or a tab or something like that. If you don't validate and normalize by like removing those things, that data on the way in, it can be really confusing, because when you do a select for it, you're going to see it not match. But when you just look at the record, you know, spaces are invisible. So you're going to look at it and say, I just searched for, you know, John Smith, and I see John Smith there, but the where clause doesn't match. Why? And it's going to be because there's an invisible space, you know, in the column that you're looking for. And that type of stuff can be really, really confusing. So a good rule of thumb, I know you're not there with, you know, Django yet, but Django has like validation things where you can validate and, you know, tweak the values that are coming in from the web form before you save it to the database. A good rule of thumb is that unless you have really good reason not to, you should always strip spaces from before the thing they type and from after the thing they type to avoid just this type issue.
I've got a quick, just little question. I noticed on some of the queries, we'll get, if it's multiple rows, it'll just return the num of rows in a parentheses, but it won't actually return the output so you can see it. Is there a way around that?
So the only way I know well, first of all, that shouldn't really happen. The only way I know that that would happen is if you did not have any select clause. I think that actually will do a thing. Yeah. Are you talking about something like that?
Yeah, exactly. Yeah.
Okay. The problem here is missing. We told it to select from those rows, but we did not tell it any columns to retrieve. So it just tells us I found this many rows, but there was nothing to get from any of them.
Got it.
Cool. Okay, so that covers select. So it covers select. Covers the very basics of select. We're going to be returning to select a lot throughout the day. But let's talk about actually adding some data. So let's run this command here of insert into context. And while y'all are running that, I will give a little bit of an explanation of what this means. So just like the select statement begins with the word select, the insert statement begins with the two words insert into. The next word in the statement is which table. What is the name of the table we're going to insert into? Next, in parentheses, we have to tell it which columns are we going to supply. Now, technically, you don't have to specify that, and if you don't include it at all, it will just say, oh, you must want to specify all the columns. But generally speaking, it's better to be more precise and name each column you care about. The reason for this is if someone were to modify the table and add some new columns, it would break your statement if, you know, those needed a, if the position there was, you know, you supply, you know, say 2 values and now there's 3 that are required, that's not going to work. Whereas if they did supply a default value, for example, this would still work. Next is a values statement. To be precise, the syntax here, where it says values, whatever, any sort of thing that returns a table set, like would be acceptable. You know, like you could actually put a select clause here. But traditionally, if you're just inserting a row, you're going to use values. And values is just the keyword values followed by a list of rows. And rows are determined by parentheses with the values separated by commas inside. That probably came out a little confusing. It's probably easier just to see it. So when we run this, we insert a row. Now let's see what happens if we insert it without a phone number. Ah, well, that's interesting. Error, null value in column phone of relation context violates not null constraint. So to figure out what's going on here, we're going to start using some PSQL meta commands. So these meta commands are not transmitted to the Postgres server. These are handled in the PSQL client. So first one we're going to do here is \d contacts. Like once you get into talking to Postgres from Django or Python, if you try and run this, it's not going to work. This is a PSQL specific thing. And what it does is it tells us about this table. So \d, you can think of it as standing for describe or display. And you can tell it the name of something. So it's going to tell us all about this table. And we have several rows here. We have column name, we have the type, collation, nullable, and default. So let's just take those one at a time. So the name of the column, in this case, name or phone, that's fairly self-obvious. Type is something that we've alluded to, but we haven't actually talked about yet. So in Postgres, every column has to have a specific type of data that it stores. It can be text, it can be numbers, it can be floating point, it can be integer numbers, it can be floating point numbers, it can be decimal numbers, it can be geometry things like points and rectangles and polygons. It can be IP addresses, it can be arrays of things, it can be entire JSON documents, it can be entire XML documents, it can be all sorts of different types of things. It can be dates, it can be times. But it is strongly typed. So for example, if we have a number field or an integer field, we'll say, and we try to insert text into it, well, Postgres is going to complain. If you're mathematically minded, you can think of types as the set of all possible values. You can think of it as a domain or a set. If you're not so mathematically minded, you can kind of think of it as a rule that specifies what types of things can go in here. Like the only stuff that can go into text is, well, text. And if you try and insert text into a date, well, it's going to reject that as well. Collation, we have this as blank. We're not really going to cover that at all. But what collation refers to is the order stuff is sorted in. So for example, if we have text, we can store text in English, or we could store text in German, or we could store text in, any of the Latin languages. And we may be able to use the same character set for all of them. But the order that stuff is sorted in will vary based on the language. So the collation tells us what rules do we use to determine, B comes after A. And the collation determines that. Nullable. This says if we're allowed to have a null value or not. Now, null is a very special and sometimes confusing concept in SQL that we're going to cover in more detail later. But for now, we'll just say nullable means empty. And by saying not null, we're saying you must provide something here, or it can't be empty. And default, we are allowed to specify a default value where if we insert a record and we don't tell it what it is, it'll just use that default instead. Whew. So with that, that's the reason that this failed. Our table definition has some rules and we broke the rules. We tried to insert a row without a phone number. Now, what about updating? So we've been able to select stuff and we've been able to insert stuff. Update is another command structure. And again, it starts with the word update. In this syntax, we tell it what is the table we want to update. Then we tell it what columns do we want to change. In this case, we want to change the phone column. What do we want to change it to? Well, the value on the right. But we also need to tell it, well, which rows do we want to update? So the where clause works exactly the same in the update statement as it does in the select statement. In theory, the database will look at every single row and it'll look at this expression here. And if it's true, it makes the update. And if it's false, it doesn't make the update. Now I said in theory because both for select and update and delete, which we'll be covering momentarily, that's the way the where clause conceptually works. But the database may be able to do it more efficiently. If it has some sort of index, it may be able to just skip rows that it knows won't match. All right, so exercise 3.1. We'll take a couple minutes here. Let's see if we can change this phone number for John Smith, that record we just inserted. I'll give you about 2 minutes here. And again, this is an ideal time if you have questions for me or Jake or for the class as a whole. Now's a great time to bring it up.
I actually have a question. For the update contact set phone, if we were to not specify a where statement, would it change every phone number?
Yes.
Okay. And
I can confirm that. I just did that.
Okay. And the other question I had was for the table definition that you showed us down there. You said that was specific to PSQL. Looking at that, is there a way to do that with the whatever we're going to be using in the future as well, just differently? Specifications.
Yes, there's a couple answers to that actually. So first of all, you probably will be using PSQL to inform the code you write. So your actual web application will probably only work if it has the columns you expect. So in most applications, you won't need to introspect the database to see what tables and columns are there. But you can if you need to. Now, even in that, there's multiple ways you can do it. So I'm more familiar with Rails than with Django, for example, but in Rails, you can ask it if you have say a contact class that represents the contacts table, you can say contact.columns, and it will give you Ruby objects that, you know, are expressing this same information here. And I'm 99% sure that'll be something equivalent in Django. But there is actually a way to do this without psql or without special support from Rails or Django. And I'll just give you the 30-second tour of that because it gets into a little more depth, but there actually are special database and tables that you can introspect to see what is the definition. So here I just selected from information schema tables, and I'll just add this where table schema. It takes a bit of knowledge to know how to use these things because there's a lot of extra tables here. But like, for example, this one here, we can see, yes, there is a table here. Table name is contacts. There's a whole bunch of information here. And then beyond that, there's also another table called columns. And this is going to give us a whole mess of output. But we could say, select where table name equals contacts. And this gives us a row for each column. So we can see we have the column name, we have column name phone, which table it comes from, which position is it in, 1 and 2, is it nullable, the data type, and a whole bunch of other things which aren't really relevant here, like the number scale, all that sort of stuff. You can see as you scroll through here, there's a bunch of different stuff. And then there's also, that is a SQL standard, that the information schema database or schema. there's also Postgres specific stuff that has a whole bunch of other information, and it also requires you to do several joins because internally it works with a bunch of numbers. So to get that information is really hard. And then lastly, if you need the information, more or less exactly like this, there is a command which I don't have memorized, so I'd have to have either me or Jake look it up. But there's a command you can give psql to tell it print out the SQL for everything it does. And if you turn that mode on when you do the \d context, it'll actually print out a page or two of SQL of all the commands that it's running to get that information to show you. And then if you needed that particular information in your program and you weren't using Rails or Django or something like that, that glossed over all this for you, you could use those queries to extract that information.
Thank you.
Oh, you're welcome. Okay, so I'm guessing we all changed John Smith's phone number, and from what we were talking about earlier, it sounds like some of us actually changed everyone's phone number. That's actually a great time to talk about how important safety is when you're connected to a database. So for now, this is just something fun to laugh at, and we're just experimenting here. But we don't actually do this connected to a production database, or you really don't want to. It's a great way to have your day go really wrong really fast. You can imagine if you're actually at a job and you just needed to make a quick update and you kind of quickly destroyed the production database, that could be well, it could be a career limiting decision anyway. So in general, there's techniques for how to safely update the database, but we'll tell you what not to do first is you basically don't connect to the database directly and just do stuff, is the short of it. If you ever have to, Jake and I actually differ on this a little bit. I think occasionally you have to. I think Jake in the past has been a little more stringent than I have about like never doing it. But I think we both agree, if you ever have to do it, you're kind of already having a bad day. And if you're not really, really careful, your day will get a lot worse. So in general, you don't want to use psql to connect directly to your production database if you can help it. Okay, so deleting a record, probably starting to look a little familiar here of like, oh, we do a thing and we have a where clause to tell us which ones. So we just delete a single row here. And again, the answer to this one is the same as with update. If we forgot the where clause, it will just delete all the rows. So this is also another reason maybe it's good that it does require you to hit the semicolon. So you can't just accidentally hit enter after you type delete from context and it happily nukes it all for you. Oh yeah, like
that's actually what got me in trouble because it was like I was doing JavaScript and I hit semicolon, semicolon, and then.
Yep. So for what it's worth, we may get to this later today, I'm not sure, but there's something called transactions where you can do a thing, you can start a transaction, you can do stuff, and it doesn't take permanent effect until you commit it. And if you change your mind, you can roll it back. We'll have to see how the day goes if we actually get to that or not. But that's another thing that if you do have to do something on production, and again, this is not something you really want to be doing, but if you have to, doing it a transaction where you make the change, then you double and triple check it before you commit it is a really good idea. And yeah, here's our notes of, yeah, it is very important to include the where clause on update and delete. Okay, so now we've covered the very basics of select. We can insert a record, we can delete a record, we can update a record. before we go on to a few more select stuff, does anybody have any questions at this point?
Jack, I have one that I was asked that I wanted to throw out to the group about types, if we have a second.
Yeah.
So one thing you might notice is Jack's talked a bit about types, and our columns all have types that we have determined. So they could be varchar, or they could be text. And I think, yeah, we have character varying in the two in context that Jack has shown on the screen. So a question you might have is like, how do you choose the type for the column? Or a question I would have if I was looking at this. The way that works is, I mean, it kind of is just an instinct that you develop over time, I would say. So the way you can develop that instinct is to just try different types that make sense to you and see how it works out. So character varying works very well for something like a name. And, you know, the way you, after doing this for some amount of time, you start to just be like, okay, I have to represent this thing. What's a good type for that? And you start to develop your own answers. The specific question I had was, why can't you use a number? Why can't you use an integer for a phone number?
Oh, that's a great question.
Yeah.
So the answer, or well, there's a few answers. One is for phone numbers in specific. What if they had an extension? What if it's, 1, 2, 3, 4, 5, 6, 7, extension 33? We wouldn't be able to represent that as an integer. But an even more important one is something you run into with zip codes. A lot of people do that with zip codes. They say, oh, great, it's a 5-digit number. I can use a 16-bit integer or just an integer value for that. Great. And then they start wondering, why do I only have 4-digit zip codes? So it's textual data in that it does not have, there could be leading zeros, for example, with the zip codes. And the leading zeros are significant. In fact, this actually brings up a little bit of an interesting story with why we don't use spreadsheets, or why you shouldn't use spreadsheets, is when you import data into Excel, unless you know the exact right incantation, it's very easy for it to see, oh, I see a bunch of numbers. Let me helpfully change those to, or I see a bunch of digits. Let me helpfully change those to numbers. So if you import a CSV into Excel that has zip codes with a leading 0, it'll helpfully remove them for you. There was a similar story recently. In the last couple months, there was some geneticists. They actually changed the symbols used for certain like DNA sequences or something like that, because people used Excel a lot, and Excel interpreted those sequences as meaning something in particular. I don't know if it was changing it to a number or exactly what the change was, but whenever they would import their data into Excel, it would munch the data. And since everybody used Excel, they figured it was easier to change the scientific name of the thing than to change Excel. So they renamed what these like DNA sequences were, or something crazy like that. But yeah, that's a little bit of an aside, but that's why you would use a character instead of a number. Another rule of thumb, perhaps, for that is this something you're going to perform arithmetic on? And if it is, it's definitely a number. But if it does not ever make sense to perform arithmetic on it, it potentially is text. There's still other reasons you would use it as a number, but that's one good criteria between them. If you're going to do arithmetic, it always will be a number. Another rule of thumb might be you use the most specific type you can. Now that that little few words there at the end of type you can, that is kind of where Jake's talking about experience and intuition comes into play, because you could use an integer for a phone number, or you could use an integer for a zip code, and you don't realize immediately that there's a problem there. So the can thing relies on a little bit of experience. But for example, if you have a date or you have a time, well, you could store that in a text field, but it's a narrower, a more precise type would be to actually use a date or time.
What if you want like use $sign and like money or percentage sign and then digits?
Sure. So there's a few places you could handle that. Typically, that type thing would be handled at the application layer. So in Rails or Django, you would either have built in, most likely, or write a little helper method that handles the formatting, at your application. If you need it formatted in Postgres, like if you needed the, let's just say you have the number here and you want a $sign in front of it, you can do things like this. Or there actually is, I think it's called formats. I might be not remembering this properly. Doing this off the top of my head, I'd probably have to look this up to make sure I got it right. Is it D? Yeah, that works. Just like you have printf in C language and pretty much all languages, Postgres has a format thing where you pass it a format string and any number of arguments and it interpolates them. This is kind of getting a little bit off in left field, but I guess the short of the answer is normally it's going to be easiest to do it in Python if that's your application language, but it can be done in Postgres if you really have to. It's just a little harder.
Thank you.
Mm-hmm. Okay, it is 11 o'clock. We usually like taking a few-minute break every hour. So let's restart at 10 after. Yay. I'll take that as a yes.
Let's do it.
Do it. Do it live. So the next thing is, what if we want the rows in a particular order? So we'll just run this and then we'll talk about it a bit. So at least one of you noticed that after the update of a row, the order the rows came back was not the same anymore. The reason for that is when you run a select statement without an order by clause, the order of the rows is undefined. Now, undefined means that there's no rule that says what it must be. The database engine will just, do whatever it happens to do. In Postgres case here, it generally would just refer to it in whatever order it reads it off the disk. And due to how Postgres implements updates and deletes, when you update something, it marks the old record as obsolete and adds the new record, potentially to the end. In this case, to the end anyway. On a big table, it might actually put it somewhere in the middle if there happens to be room, or there's, it's undefined. If you look at the Postgres source code, you probably could figure out what's going to happen. But from our point of view, we don't know. It's best just to think of it as unknown. So if you ever care about the order things happen in, you always have to use an order by clause. And the order by clause comes after the where clause. And again, it's actually a list of expressions. So we're going to say order by name, and it just defaults to either ascending or descending. The default is ascending, and we can also tell it to be descending. Now, it might seem a little weird to say, what does it mean for letters to ascend? Well, every letter has like a numerical value or position. And in English, we would say that, you know, A is less than B and B is less than C. And if you go way back down into the history, you can look up like an ASCII table, it was like ASCII, I think it is. And you can actually see what the numbers are in the old days, and then they imported that into Unicode, mostly unchanged for the first 100 or so. But then even that can be changed by that collation stuff we talked about. But basically, every letter has a number that represents it, and that's what it actually uses to compare it by, modified by the collation again. Any questions, any issues with that? Cool, okay. So we can also add a limit clause. A limit clause just says, how many rows do you want to get back? So combining order by and limit is a great way of saying, I want to find the most or the least. You know, I want to find the top 10 or the bottom 10 or the first or the greatest or the best or the worst. That is the type thing that you'll use, you know, order by some condition, limit 1, and that gets me, you know, the best or the worst. Or order by some condition, limit 10, get me the top 10 or the bottom 10. Not really too much more to say about that. Does that make any sense? Okay, again, I'll take that as a yes. Okay, so now we're into the idea of how do we tell rows apart? We've got names, we got phone numbers. Well, people have the same names. You know, there's a lot of John Smiths in the world. People also can share phone numbers. You know, nowadays with cell phones, it's less common, but you know, you go back a few years and people would have a home phone number and there might be 4 or 5 people that all shared the same phone number. Even today, people change numbers occasionally. You know, whatever phone number you have, somebody else probably had it years before you. So phone numbers can be shared, names can be shared. How do we tell these rows apart? So we need some way to uniquely identify the rows. And in database terminology, a unique identifier is called a key. And the most important unique identifier is called the primary key. Why I say the most important is because sometimes you'll have more than one unique identifier. But you should, with very few exceptions, always have at least one. And the most important one is called the primary key. So we are going to run this next command here. And this one, I don't mind at all if you all just copy and paste this instead of typing it, because I have no illusions that anyone is going to remember this. I have to look it up when I do this type of stuff, and I've been doing SQL for a lot of years at this point. In fact, that's a general thing to talk about a little bit here. How much of this stuff do you really need to try and memorize versus how much do you look up? And I'm on the side of remember what you can do, but look up how to do it. You know, after you've been doing SQL a few years, you'll probably remember most of the things, you know, basic select, update, delete, insert. Probably even remember some of the basics of like alter table. But a lot of these things, if you only end up doing it like every month or so, like even this command here, add a primary key. Well, 99% of the time, you're going to create the primary key when you create the table. So knowing how to alter the table to add a primary key is not something you're going to do very often. So looking something like this up is perfectly expected.
Yeah, Jack, I'd add to that. When you're first learning this stuff, you know, you're trying to remember the syntax. And then I think there are some people who can just type this out straight from their brain. you know, those people are incredible. Jack's probably close to that that realm, but I think what most people settle on is they know what they know the concepts, and then they just have to look up the syntax. That's where I'd say I am. Like, if I want to add a primary key, I know I need to change the table, and I know that that's alter table, and then I know I want a primary key, and I want it to increment with the identity function. So it's like knowing those words is enough to find the answer for me, because I could search for those on documentation or on Google or whatever. But you have to do some work to get even to that point, I think, just knowing what the rough terms are.
Right. Yeah, I agree. That's the thing. You want to remember that you can do it in a few keywords. But like, I mean, I'm on the Postgres docs. I'd be very surprised any day that I wasn't on the Postgres docs multiple times a day.
Would you mind demonstrating like the help command for alter table, Jack, just since we're talking about docs?
Yeah.
I think if you do like slash.
So, is it help or just H? I forget.
I think it's help.
Ah, yeah.
I wanted to point this out just because in your P-SQL you have like the docs. You have much of the docs are in your REPL all the time. They change color on Jack's terminal because he's got a cool pager, but yours won't do that. But these, if you're like trying to figure out how to write the statement on line 87 of the text editor, this will tell you that this language is not. This language takes some learning to understand how to read it, but it does explain how the syntax all works. So this was something you could check out as well.
Right. Yeah, and as far as this language here, this is not necessarily specific to Postgres. When you see like real technical programming documentation, you'll often see stuff like this. In the, if it's in square brackets like this, that means this is an optional clause. If it's just directly specified like this alter table, that's saying it's required for this form. But anything in the square brackets is optional. When you have comma, dot, 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 that's saying you could have multiples of these separated by commas. Let's see, I think there's a curly brace one somewhere. Like this set or drop, one of these is required, but only one. So, you know, you can say, you know, set not null or drop not null.
Yeah, looking at this table right now, if you go back up to the top, you can construct Jack's query from almost everything shown on the screen, right? Because the first alter table help thing there, it says alter table, and then if exists, we don't care about that, and it's optional. We don't care about only, and then it says name. So name is the table name. So that's the first line of Jack's SQL query, alter table contacts.
Right.
And then farther down it says where action is one of. So the first one is the one he did, which is add column. He chose to use that. Then he got rid of the if not exists column name, which is the ID. Data type is the int in his string, and then I think farther down you'd get that generated stuff. But it's all you can construct the whole query from this help page.
Right. Yeah, it's definitely not easy to read the first time or 10 times. Yeah. But if you know what you're looking for, it can help you find it. You know, really just Googling, you know, Postgres add primary key, you know, but you need to know what a primary key is, which is kind of the key thing there.
Yeah, I put a link to the Postgres docs in the Mike Platoon channel. They're really good. They're probably the best docs for any open source project, I think. And everything you'd want to know how to do, there's a page in there explaining it.
Yeah, definitely. So let's look at this context table. If we describe the table, we now see we have an ID, new column. And if we do the select star from context, We now see that that magic phrase generated by default as identity, that now gives us, you know, a number that increments for each one. Now, if you look at older documentation, or even, it doesn't even necessarily have to be old, but there's an older style you may see where the type is like serial or big serial. That is a Postgres specific version of this generated by default as identity thing. This is standard SQL, which Postgres just added in the last couple versions. And it handles a few edge cases better. So I would say this is the preferred style now. But if you see something that says serial or big serial, that's basically the same thing. Okay, so we have contexts, and contexts have IDs now. Well, if this is the phone book on our mobile phone, it also should keep track of when have we talked to these people. So let's add a new table. I'm going to create a table of calls. And again, this is something that in general you'll need to look up for a while, but we'll kind of talk through it. So this one, we're going to start with a primary key. Then we're going to have the contact ID, which is an integer, and that is going to refer back to the contacts table. So like on my screen, I have like Lydia Vandervoort is ID number 2. So if I want to record a call to Lydia Vandervoort, I'm going to say contact ID is number 2. Then we have two new types here. We have timestamp TZ, and we have interval. So let's talk about that a little bit. So what is a time? It's kind of a philosophical question, but it actually kind of relates to this. If we want to store the time something happened, what do we mean by that? Well, what I would mean by it anyway is this is a point in time. It's like when an event occurred. And in particular, that idea of a point. So does a time, if we say something happens, you know, on July 16th, you know, 2012 at 12:57 p.m., does a point in time, does it or should it include a time zone? If we want to know the exact instant something happened.
We could use like Zulu. We could use Zulu time, put everything on Zulu.
Yeah, so that's one way of approaching it, of saying we're going to convert it all to a single time zone. What that implies, and in fact, that is what we're going to do indirectly, but that implies that, yes, we do need a time zone, you know, even if it's a specific one. If we don't know the time zone at all, you know, well, it could be, you know, what, up to 24 hours off or 12 hours off either direction, you know, depending on what time zone it really happens. How about dates? I mean, they potentially have a similar issue, you know, with the international date line. If we want to say, you know, it happened on this day, well, usually the day has to include a location, like what reference point are we talking about? So I guess the short answer to both times and dates is they do need to include time zones, or at least the time zone needs to be known. How about a crazier question? Can time go backwards? In fact, this is particularly apropos. Say, what is it, 4 days from now, 5 days from now? Anything strange going to happen?
Are we talking about savings time?
Yeah.
Oh.
So early Sunday morning, we're going to have, what is it, 1:30 a.m. will happen twice. So we get to 2 and then we go back to 1. So as we record time, can appear to go backwards. Or at least it can if we do not include the time zone or convert to a time zone that does not have daylight savings time. To even get crazier, there is even things like leap seconds, which is even messier, and we're basically just going to ignore that. But then further, do all dates and times exist? That's kind of an interesting one. Can anybody think of some examples where a date or time doesn't exist?
February 29th.
Yeah, that's a good example. It exists 1 year out of 4, but it doesn't exist, 3 years out of 4. Another example for time would be, we've talked about the time change. We're going to fall back in a couple days, but come spring, we're going to lose an hour. So we have a clock time that never exists. You want to get even crazier, if you go back in history several hundred years, you have entire weeks of time that don't exist. When you had the calendar was not correctly handling things like leap year, and the calendar was starting to shift from actually what the seasons were. And they corrected it. But the correction actually meant a jump of a couple weeks. Well, this was also happening at the time of the, post-Reformation and the division between Catholics and Protestants. And when the Pope said, we are going to change the time, the Protestants said, who are you to tell us what to do? And various countries decided to move to the corrected calendar at various times. And this took place over the course of, I think the last one to switch might have even been in the early 1900s. I might be off on that, but there was about a century where different countries moved at different times. So if you are talking about such and such country, there'll be, April 22nd is followed by, May 15th or something like that. And there's only one actual day between them. So that's another thing that fortunately we don't have to worry too much about. But it's basically times and dates are really a mess. And you want to use something like Postgres that supports, it'll actually figure those things out. In fact, I believe it does support that whole Gregorian calendar mess, where if you actually say how many days are between, 1000 AD and 2000 AD, it'll actually give you the correct number, not the, simple, well, multiply by 365 and a quarter. It'll actually do that right. It'll handle, leap years are actually, there's another thing that happens based on, was it every 100 years or every 400 years? It's not quite every 4 years. Anyway, there's a whole lot of mess there. Time zones are the worst, but these other ones affect us sometimes. And Postgres handles it if you use their date and time types. Interval is also interesting because another question is every calendar day the same length? Well, no. If you live in a daylight savings time region, once a year you have a 23-hour day, and another once a year you have a 25-hour day. So if you were to do something like say, oh, I need to advance by a day, so let me just add 24 hours, twice a year you're going to be wrong. I know that personally. I worked on a time clock thing and I did that wrong back in the day. So dates and times are messy. You should use the built-in dates and time types and functions to do stuff with it. Okay, so with that little digression into how terrible time is, let's insert some call records. So we can just copy and paste these for expediency here. You can see that the time type, or the timestamp TZ type, looks fairly simple, or it looks self-explanatory. The call duration, you can either use, hour colon month, or hour colon minute colon second. You can use that style, or you can actually spell it out in words. The words type can actually be kind of nice because that handles the stuff where like days and months are of different lengths, for example. Another thing here is new clause is the returning clause. So after you insert a record, you can put essentially a select at the end. It's called returning, it's not called select, but you can use expressions from the newly inserted row. 99 times out of 100, all you care about is what was the auto-assigned ID. So we're just doing returning ID here. And that lets us say, if we want to select star from calls where ID equals 2, we get back that record. Now, here's another example of us purposely going to crash into a wall to explain why the rules exist. So what happens if we insert a call for a contact that doesn't exist? We only have about 20 contacts. Our contacts ID go like 1 to 20 or something like that. There is no contact ID 99,999. But it let us insert that. It happily did it for us. That's a bit of a problem. That is inconsistent data. So let's delete that record. So we're going to run this delete from calls where ID equals, and you can replace whatever ID number yours did with the returning ID. If you've been following along directly with me, it'll be 3, but if you've experimented a little bit, it might be a different number. So we'll delete from calls where ID equals that last ID. And we're going to run this statement here, alter table calls add foreign key. So we can run this. Now we'll talk a little bit about what this means. So a foreign key, it's foreign as in it belongs to another table. So we're saying that contact ID is a key that exists in a different table. Well, which table? Well, the table it's referencing is contacts. And which column in that table is it referencing? Well, it's referencing the ID column. So when we ran this command, it just told us, okay, I altered the table, but it didn't really say much more than that. But what we can do now is let's repeat that erroneous insert. And yeah, it looks like I got a little typo there. So this should actually get a copy and paste error there. So actually, we can just repeat the one that was above it. That's annoying. I said repeat. I should just copy and paste it myself. Okay, sorry about that. So let's try this insert. All right, now we get a useful error. It tells us that inserting or updating on this table violated that foreign key constraint because contact ID 99,999 does not exist on that other table. And this is where this combination of foreign key constraints and what we're going to talk about next, which is joins, this is where relational databases really start to show their power. It's when we connect multiple tables together. So first, we're going to have a rule of thumb is that you almost always want to use a foreign key constraint. If two different tables connect these things together, you should enforce that rule. But how do we make these tables work together? Now we're going to get into joins. And joins is if there was a single feature of a relational database that is probably its standout thing that people think of, it would be joining tables together. So we're going to start with the very, very simplest one, and that's a cross join. I'm going to make my window a little bit bigger here, because I'm going to get a lot of output here. So when we run this, something interesting happened. You notice we got 38 rows. 38, that's kind of interesting. It's interesting because, well, how many calls do we have? We have 2 calls. How many contacts do we have? I have 19. You know, if you've done any extra inserts or something, you may have a slightly different number. 2 and 19 and 38. I start to detect a little bit of a pattern here, like maybe it's 2 times 19. And that's exactly what's happening here. A cross join says, take every row of a table on the left and give me every combination of rows on the right. So we can see here that like this 4th column here of ID, this is the calls table ID. I don't know, can you all see my mouse pointer when I'm pointing?
Yes.
Does it show up? Yes? Great. Okay, so this 4th column here, notice it only has 1s and 2s. So this joined, you know, we have 2 calls. The first call, it joined with every contact. And then the second call, it joined with every contact. Now, you're probably saying that's not terribly useful. And you're right, that's not terribly useful. And we will very, very, very rarely use a cross join in production work. I'd say, trying to think, if I use it every couple months, maybe something like that, and I do a lot of SQL. So it's a pretty rare thing. But this gives us the insight to what we're going to do next. So the next thing is just a regular join, or it's also called an inner join. We can type inner here if we want, but since it's not necessary and I like typing as little as possible, I usually leave it out. So let's run this command, see what happens. Oh, well, that's starting to get a little more interesting. So now we have the call and we have just the contact that connects to that call. So in particular, you notice the contact ID column here always equals the ID of the contacts table .id is equal to the calls table, you know, .contact ID. And if we look back at when we did the cross join, every row for which those were equal is included. Every row for which they are not equal was excluded. This is really almost a fundamental thing as far as joins. And we can kind of see it as in this, our original 38 rows. It might even be worth going through a few of these by hand. The Postgres actually looked, this context.id equals calls.contactID. Anywhere that's true, it includes the row. So this one here, is this true? Yes, so it includes it. Is this one true? No, 1 does not equal 2, so it excludes it. 1 does not equal 3, exclude, exclude. It excludes all of these. It goes through every single one and says, does contact ID equal ID? And for all the false ones, it throws away the row. Then when it finally gets to this other row where it's true, it includes it. Any questions on that? This is usually something that confuses people. It can be very confusing, but it's also very important. So I don't mind spending some time here with like more elaboration or more examples if we've got any questions. Okay. All right. I'll just take this. We got a really smart class this year. All right.
Here, I have a question.
Okay.
So what would happen instead of join calls on, you did join calls where?
So that would actually be a syntax error, because the join requires, if you do an inner join, it requires it requires an on clause. So if I run it like this, it's just going to say, oh, you got a syntax error. It's not an especially helpful error. It doesn't tell you it's missing on, but that's what it's complaining about. Now, you do bring up kind of an interesting point, though, and that is that more or less, we could consider cross join with a where equal to an inner join with an on. So we could do this and get the same result. And as far as what the Postgres engine actually does, it's almost certainly going to do the exact same work. However, why the inner join style is preferred, and if you look at like real old SQL stuff, like 20 or 30 years old, you may find more stuff that is this style, and in fact, even more than that. You might see this style. A comma, if you see just a list of tables with commas between them, the comma is equivalent to a cross join for whatever that's worth. If you're looking at old material, you may see that. And old style stuff did do this style where it's just from list of tables and then where and all the conditions there. Now, why that style is inferior to this style of join and on is because if you put it in the on clause, that ascribes meaning to it to the next programmer who's going to look at this. And that meaning is, this is the condition that controls how these tables are joined together. And then once these tables are joined together, you can still add a where clause, and the where clause says, okay, now that I've got these rows, now how do I choose between the rows? How do I filter the rows?
All right, cool. Thank you.
You're welcome. Any other questions on joins? Like I said, this is kind of a really important concept.
I just have a quick question, not totally about join, but what was the best practice again when dealing with time?
So you're going to want to, well, at the high level, the best practice is you're going to use whatever libraries are built in. You never want to just say, oh, well, I can just add, I know a day is 24 hours, or even just I'm going to add an hour and just, increment this number or whatever. You want to use the libraries that are built into your language, like Python if you're at that level, or the stuff that's built into Postgres. In Postgres, you basically get it implicitly by using the timestamp TZ type or the date type. Timestamp TZ stands for timestamp with time zone. There also exists timestamp without time zone, which in general, I'm just going to recommend you don't use that. Now, confusingly, timestamp with time zone does not have a time zone. The naming is kind of pretty terrible there. What it really means is what was suggested earlier. What if you just always converted to a given time zone? So timestamp TZ automatically converts to UTC time and stores it in that, and then it automatically converts it on the way out as well. So the rule of thumb or the best practice there is store times with either directly with time zone information, or like in this case, with something that auto converts to UTC and converts back.
That's perfect. Thank you.
Mm-hmm. Okay, well, for reporting, there's some other fun stuff we can do. So let's just run a couple of these here. We'll cover these pretty quick. Select count star from calls. That tells us how many rows are in the calls table. Select sum call duration from calls. That tells us what is the total amount of time. You know, it sums every value of the call duration. We could also say, what is the average call time? Now, aggregate functions, the way I like to think of aggregate functions is aggregates are like a bucket. And you have many rows, or another word for it, if you're familiar with MapReduce stuff, you could also think of them as reducers. You have many rows that go in and fewer rows come out. So in this case here, we are just aggregating things and we're not telling it anything about how many buckets or how many groups to have. So it just says, oh, you must want one group. So I'm going to tell you how many rows there are in total. I'm going to average or sum all the call durations. But it might be nice if we instead were able to choose what are the buckets or what are the groups. So let's run this command here. Select contact ID and count star from calls group by contact ID. So this tells us that there was one call made to each of those two contacts. So why don't we've only got one row for each of these two contacts. Why don't we add another one here? So what if we were to insert into calls, how about we say, insert a contact ID, we're gonna insert call start and a call duration. And we'll insert one for contact ID 2. You can put in whatever call start and call duration you want. And then we can rerun that previous group by here, and we should get, yeah, we have 2 rows now for contact ID 2. And you can even add a third one if you want, just, you know, up arrow a few times, just change this a little bit. So here's how this actually is working, or the mental model we should use for how it's working anyway. So we start with the select star from calls. So this is the initial data set that gets fed in. What we tell it to do is we tell it we want to group by the contact ID. And then within each group, we're going to count. Count star is kind of a special form that says just count how many rows there are. There are a few other forms we can use, but count star is the most common. So when we get here, there's 4 rows to start with. We get to this row, and here's what Postgres does. Postgres says, oh, contact ID 1. Do I have a bucket for contact ID 1 yet? Or do I have a group for contact ID 1? I do not. So I'm going to start a new group for contact ID 1. and I'm going to run this aggregate function, this count, and I'm going to put this row through it. Now, what does count do? Count just says every time I get a row, I'm going to increment the counter. So we now have a group for contact ID 1. That group has the counter of 1. Okay, we've handled that row. We go to the next row. Oh, contact ID 2. Do we have a group for contact ID 2? No, we do not have a group, so we need to create one. So we create the group for contact ID 2, and we pass this row into it. Well, all the count aggregate function does is increment a counter. So now we have contact ID, the contact ID 2 has a count of 1. We feed in, we get to the next row. Postgres says, hey, does contact ID 2 have a group or a bucket already? Yes, it does. All right, we'll pass this row into that aggregate function or that reducer or that group. And what does it do? All it does is count how many rows there are. So, oh, another row came in, let me increment that. So now there's 2 rows. We go to the next row. We get to contact ID 2. Do we already have a group for that? Yes, we do. Pass that row into the aggregate function. All it does is count, so it increments it again. So we have 3. So now we have 2 buckets or 2 groups, one for contact ID 2, and the count was 3, one for contact ID 1, and the count was 1. The same type thing happens if we are to use sum or average. In this case, what happens here? Well, we get to the first row. Do we have a bucket or a group for contact ID 1? No, we don't. Well, let's start a new bucket and let's call that aggregate function of sum call duration. So we pass this row in. All it cares about is call duration. Actually, this one here. So it adds 3 minutes and 23 seconds to that bucket. Goes to the next row. Do we have a bucket or a group for contact ID 2? No, we don't. So let's create one. Let's pass in this value, this row. Okay, it's 7 minutes and 2 seconds. So it adds that to its increment, or it's a sum. It's running total. We get to the next row. Oh, we already have a bucket for this. Add 1 hour, 47 minutes, 52 seconds to it. Here, again, we still have a bucket. We add 45 seconds to it, and we get this output. Same type thing happens with average, only it would internally keep track of both the sum and the count. And then finally at the end, it would divide them. So we end up with, the average time. It's 38 minutes for our calls to contact ID 2, 3 minutes for contact ID 1. Now, here's a question. Why doesn't this work?
It can't group all that information by contact ID because you're not paying attention to call start.
Yeah, call start is definitely the problem here. And we can see what happens if we run through this by hand again. So when we selected through all this stuff, we have a contact ID, we have a count. But for contact ID 2, we have 3 different call starts. Which one should we choose? Well, that's a good question. I mean, it might make sense to say, well, we should choose the smallest one or the first one. Or maybe we should choose the biggest one or the last one. Or maybe we should average the times. Or maybe we made a mistake and this is just like not a valid question to ask. I mean, it just doesn't make sense. So Postgres is not going to assume. It is just going to say, hey, you asked me a question, but you did not specify it correctly. You did not ask a question that is answerable. This is actually another example of Postgres versus MySQL. And some of the things I talked about earlier were historical. I believe this is actually still accurate. MySQL will actually just do this, and it'll give you, I believe it'll give you the first row it happens to run into. Whereas Postgres says you have not specified the question precisely enough. MySQL says, let me just guess what you meant and answer that question. So one other thing we can do is we can run multiple aggregates in a single query. And it works kind of the way you would hope. I'm not going to go through every line. You're probably tired of me talking about bucket 1 and bucket 2 over and over and over again. And if you're not tired of hearing it, I'm tired of saying it. So I don't feel like doing it again. But it basically works like you'd expect to. And lastly here, I think we'll do this one last thing. Let's see how much more we got with this. Yeah, we're gonna break before we finish this, so it's time for lunch. We'll do one more thing here and we'll finish up the last 5-10 minutes after lunch. So where we really start to get some power here, or even more power, is when we combine joins with aggregates. So what's happening here is, if you recall way back when we did that join without any aggregates, this is essentially our table that gets fed into the group by, because we joined those things together. But then each row gets fed into that group by, just like what we did before. Only our groups, we're going to group by the contact ID, and we're going to group by the contact name. So that specifies what our buckets are, or what our groups are. And by doing this, we not just get the aggregate information, we also get something a little more meaningful. Like, it's a lot more meaningful to me to say we talked with Lydia 3 times versus we talked with contact ID 2 3 times. So far, so good. All right, well, I think it's a good time to break. The next thing we're going to talk about is left joins, which will warrant a little bit deeper explanation. And it's 12 o'clock, so I guess we'll break for lunch and reconvene at 1.